So a little bit more about dominance before we get to an activity where you get to do a little bit more work practicing. Yet another Socrative poll that I gave you, talking about brachydactyly. And I was surprised, 19 said that this genetic disorder is caused by a wild type allele, 36 mutant allele, 10 can't tell. I'm going to take the temperature in the class right now. Does anybody want to change their vote? What is brachydactyly caused by a wild type or a mutant allele? So is it? How do you decide?
It's not what's common.
Depends on the population you're looking at, but in this room, for example, everybody. No, I suppose we shouldn't ask people to show us their phalanges. It's probably true if you go out into our population here in Fresno that most people don't have brachydactyly. So it's caused by a mutant allele. There's a genetic difference that causes this developmental alteration. Okay. Easy. Now, this is where things get tricky. Is this a dominant or recessive mutation that causes brachydactyly?
Or recessive?
Okay, so why is it recessive? Well, I want to make sure I take each.
Because if it was dominant, then all it would take would be at least one version of that allele to be in the population for it to be more pronounced. So if it's recessive, then it could you could have it but not express it, which means that you'd have less people with.
Okay. Does anybody else want to add to that? Yeah, go ahead.
I'm kind of comparing it to like in horses, the black gene is dominant, but you rarely ever see black horses. So the recessive alleles are more common, but doesn't make them dominant.
Okay. So contrasting opinions. We've got one opinion that if a genetic disorder is rare, that probably means it's recessive, because if you do a cross, as we've been looking at in class, if you do a cross between two individuals that have brachydactyly, so let's say it's dominant, let's assume it's dominant, capital B causes brachydactyly, then you'd get our normal 3-to-1 ratio of brachydactyly to what's little b over little b then? Non-brachydactyly, which we would call probably wild type. It's what almost everybody in this room has. So this sort of sets up that, wait a second, so if it's dominant, then shouldn't 75% of people have brachydactyly? By the way, don't fall for this because I'm misleading you at the moment. The other camp is just because there's a dominant allele doesn't mean that it's common. Right? So horses, black gene you said?
Black gene is the dominant one, but you rarely see a black horse. It's not, rare, but it's not common.
Except for the black stallion. Right. So this is a really important point about dominance and predominance. And I want to take you all back in time to the prestigious, heady scientific days of 1908, don't memorize the date, to when Dr. Hardy of Hardy-Weinberg Equilibrium, which we're going to get to eventually, a famous geneticist now, writes this sort of academic smackdown in the journal Science. It starts, I am reluctant to intrude into discussion concerning matters of which I have no expert knowledge, and I should have expected the very simple point I wish to make to have been familiar to biologists. However, some remarks of Mr. Udney Ewell, to which Mr. Punnett, yes, of Punnett Square fame, has called my attention, suggest it may be worth making. And here is that quote. If brachydactyly is dominant, as I just drew on the previous slide, if brachydactyly is dominant, this is what Ewell is saying, then wouldn't we expect to see 3 brachydactylous individuals to every 1 normal wild type person? In their case, if you have 2 brachydactylous individuals have offspring, they would be a 3-to-1 ratio of their kids. In that family, yes, 75% of the offspring would have brachydactyly and there'd be 25% that didn't. But when that one couple in their family is having a 3-to-1 ratio of brachydactyly, what's happening to every other family and the kids they're having?
Would this be like skipping a generation?
This pedigree, and we're going to get into pedigree analysis in a little bit, shows that it doesn't skip a generation. That's something that we'll see we expect of dominant disorders. And that's how physicians first found out that brachydactyly is dominant. Because they look at it and they see brachydactyly, the filled in symbols, the black symbols, from generation to generation to generation. Every generation there are some brachydactylous individuals in this family. But if that one family is having 3 brachydactylous kids and 1 wild type kid in their family of 4, how many people with brachydactyly do you know? Anybody? Okay, so in our population, what's the frequency of the brachydactyly capital B? It's 0. None of us in the population we're defining as this class plus our friends, acquaintances, there are 0 brachydactyly alleles. So in the case where there might be a family out there that is producing, in a dominant fashion, offspring that have brachydactyly, every other family in our population is having the same number of kids, 4, and none of them have brachydactyly. Because that allele, the dominant allele, isn't in the mother or the father that are producing those kids. And that was the point of that letter that was written in 1908, was that yes, in an individual family you'd expect a 3-to-1 ratio of offspring, but in every other family where there is not the brachydactyly allele, you don't produce any brachydactyly offspring. And so a rare allele is rare. It doesn't mean that it's dominant, shows up in every generation in the cross, but brachydactyly is not predominant. Nobody here at least admitted to knowing anybody with brachydactyly. It's a rare medical condition. So just because it's not wild type, which is common, because it's mutant, because it's rare, doesn't mean that it has to be a recessive allele. So this is just a rare example of a dominant trait that's rare.
So someone who's heterozygous would express a phenotype that's brachydactyly.
Right. So a heterozygote or a homozygote for capital B would be brachydactylous. And the only genotype that produces wild type is little b over little b. But if the frequency of capital B is, in this room, 0, let's say it's 0.01, let's say one individual in 100 has a brachydactyly allele, then what's the frequency of the little b's? 0.99, because frequencies have to add to 1. So that just means that, yes, when brachydactyly exists out in the world, it's dominant. It goes from individual to individual in that family. But at the same time, the other 99 families that are having kids don't have the brachydactyly allele, so they don't pass it on. It stays rare. Even though it's dominant, it passes from generation to generation, every generation.